Hello students, how are you? Today we shall read about the periodic properties, and the periodic properties we will discuss what are the periodic properties, how we can say that is periodic properties are going to be changed into the periods and the groups. So in that one we should know that is today we will discuss all the properties or all the topics in the English only. So periodic properties, before starting the periodic properties we should know about the periodic table. As we know that is the periodic tables are divided into 7 periods. First we should know it is divided into 7 periods and 18 groups. 7 periods and 18 groups. And the periods matlab means we can say that is the periods means the horizontal rows are known as the periods. Horizontal rows. Okay beta. And 18 groups means vertical columns. This is known as vertical columns. Vertical columns are known as the groups, and horizontal rows are known as the periods. So this all the elements, all the 118 elements are divided into 7 periods and 18 groups. After that we should know that is what is the periodic property or what are the periodic properties. We should know that is what is the periodic property. Periodic properties are the properties of the elements which repeat after the fixed interval of the time. The properties which repeat after the fixed interval of the time. After the fixed interval time means either in the groups or in the periods, so then they are said to be the periodic properties. The main periodic properties, how we can say that is the periodic properties are number 1 atomic, number 1 beta atomic radii, atomic radii, and number 2 ionic radii. We will discuss one by one. Ionic radii. Number 3 beta electron, electron gain enthalpy, that is the third one. Fourth one we can say that is the ionization potential is the third one. Ionization potential. Okay, and after that number 4 electron affinity. It is known as the electron affinity. Number next electronegativity. Electronegativity. After that we can say metallic and non-metallic character. But these 5 are the main periodic properties. In that one, according to the name, we will discuss one by one. What is the atomic radii? What is the ionic radii? What is the ionization potential? What is the electron gain, electron affinity, electron gain enthalpy? What is the electronegativity? So we should know first atomic radii. Atomic radii. What is the atomic radii? So let's see. That is atomic radii means if we are talking about the atom, and suppose this is the center of the nucleus, so then we can say the distance between the center of the nucleus to the outermost cell is known as the atomic radii. Understood? The distance between the center of the nucleus to the outermost cell is known as the atomic radii. This atomic radii can be further divided into the following parts. We can see one by one. This atomic radii of the following types. Atomic radii may be covalent radii. Parts are the covalent radii. Okay, this is the first one. Second one we can say van der Waals radii. Van der Waals radii. Number 3 inert gas radii. Okay, or number 4 is known as the metallic radii. It is metallic radii. So here we can say that is atomic radii can be classified into the following types: covalent radii, van der Waals radii, inert gas radii, and metallic radii. So these are the atomic radii. Now we will know, that is, we should know that is the trend, general trend of the atomic radii. General trend means when we move into the period from left to right, then what will happen? When we will go top to bottom in a group, then what will happen? So general trend of the atomic radii should be, let's see how we can say that is a general trend of atomic radii. When we are moving in a period, this is the period. When we are moving in a period from left to right, so then atomic radii decreases. Okay, beta, generally. And when we are moving in a group from top to bottom, so it increases. Okay, bachcho. So therefore, we can say in the period it decreases and in the group it increases. What is the cause behind it? This is based on the two factors. One is number of cells. Okay, number of cells. If number of cell increases, so then atomic radii increases. And number next one, nuclear charge. Number next is nuclear charge. So therefore, on the basis of these two factors, we can say atomic radii increases or decreases. Number of cells, now I have told that is it is decreasing into the period and it is increasing into the group. Why? What is the cause behind it, beta? So we can say number of cell, okay, is directly proportional to atomic radii. Atomic radii. If atomic radii means number of cell increases, then atomic radii increases. Number second, nuclear charge. Number next, nuclear charge. Nuclear charge means it is inversely proportional to the atomic radii. It is inversely proportional to the atomic radii. It means if nuclear charge increases, then atomic size decreases. So on the basis of these two factors, we can say atomic radii decreases when we will move in a period from left to right, and it will increase when we will go from top to bottom in a group. So this is all about the atomic radii. After that, we will discuss the second one, second point, second periodic properties. That periodic property is ionic radii. Next one, ionic radii. What is the ionic radii? The radii of, the radius of the ions is known as the ionic radius. Suppose we can assume here sodium. Sodium, its atomic number is 11, electronic configuration we can make 281. If we are going to form the sodium ion, so it will lose one electron. You can see. And if you are going to make the electronic configuration, so it has 3 cells, but in the ion it has 2 cells. So therefore we can say number of cell decreases. So number of cell decreases means ionic radii decreases. Second one, suppose we are talking about the chlorine atom, its electronic configuration is 2, 8 and 7. For chloride ion, its electronic configuration to be 2, 8 and 8. So here number of cell remains same, 1, 2, 3 and 1, 2, 3, but the nuclear charge decreases. In this case, nuclear charge decreases, therefore its radius is going to be increased. This is atom or this is ion. This is atom and this is, then we can say that is the size or radii of the cation is always smaller than its parent atom, and the size of the anion is always greater than its parent atom. So therefore we can say that is why the size of this one, because number of cells decreases. Here 3 number of cells and here only 2 number of cells, and here number of cells remains same. So therefore we can conclude on the basis of the nuclear charge. So nuclear charge decreases in this case, therefore ionic size increases. So we can say that is when we move into the periods, then ionic radii decreases, and when we move from in a group from top to bottom, so then it will increase. So this is the general trend of the ionic radii. Now after that, the third point we will discuss. Third point is ionization potential. What is the ionization potential? ionization potential. Ionization potential means the amount of energy required, the minimum amount of energy required to take out one or more electron from the outermost shell of an isolated gaseous atom. Suppose one atom is there and this atom is converted into the isolated gaseous form, and from that isolated gaseous atom, if we are going to take one or more electron, so then whatever the energy is required, that is known as the ionization potential. Once again I am repeating, the minimum amount of energy required to take out one or more electron from the outermost shell of an isolated gaseous atom, then it is known as the ionization potential. Ionization potential means, suppose we can say sodium is there. If we are going to take one electron from the sodium atom, so then it will form the sodium ion. So for taking out this electron, whatever the energy is required, that is known as the ionization potential. Now the general trend we can say, beta, when we move into the periods or when we move into the groups. So when we move into the periods, so then it will increase, means it is increases. It increases into the periods and it decreases into groups. Okay? It decreases. What is the cause behind it, beta? It increases into the period from left to right because atomic size decreases. Atomic size decreases means if the atomic size decrease, so then there will be more attraction among the electrons and the protons. Therefore, for that one, more energy is required to take out the electron. Therefore, it will increase. And from top to bottom, the number of cells increases. Number of cells increases means number of cells 2, 3, 4, 5, whatever is there. If more number of cells are there, so then there is a less force of attraction among the nucleus and the outermost shell. Suppose this is the situation. Yes or no? This is the situation. Electron is there and this is the nucleus. So therefore, this electron and this proton has less force of attraction in comparison to this electron and this proton. So we can say as the number of cell will increase, so the force of attraction among the electron and the proton will be less. Therefore, it is very easy. It is very easy to take out the electron from the bigger atom. Means if the atomic size increases, so then ionization potential decreases. So this is the cause behind it, means why it is increasing and why it is decreasing. Okay. Now the next point is electron affinity. Next point, 4 point is electron affinity. Electron affinity. What is the electron affinity? Electron means beta, electron affinity means to love, to attract. So electron affinity is the characteristics, and we can say when an atom, suppose Cl is there, when an atom accepts one electron to form the anion, so then in this category it releases, it gives some energy. So that is known as the electron gain enthalpy. So electron gain enthalpy is the amount of the energy released when an atom accepts one electron to form the anions. So this is the electron gain enthalpy, and the characteristics of this element is known as the electron affinity. What will be the changes into the periods as well as into the groups? In the periods it will increase, means in the period it increases and in the group it decreases. What is the cause behind it, beta? It increases because atomic size decreases, and it will decrease because the number of cells, atomic size increases. So we can say that is electron affinity or electron gain enthalpy increases into the periods from left to right, and it decreases from top to bottom when you move in a group from top to bottom. So this is known as the electron affinity. One more thing I would like to tell you, suppose one atom accepts one electron, so this form O minus, and this O minus accepts one more electron, so then it is O minus. Let's see beta, in this case the energy will be released. In this case energy will be released, so therefore we can say electron gain enthalpy will be positive, and in this case electron gain enthalpy will be negative because this negatively charged ions, when accept one electron, so then it form the negatively charged oxide ion. So in this case energy will be absorbed, and in this case energy will be released. So therefore one is positive and one is negative. And as I told, that is in a period it increases and in a group it decreases. Okay. Now the next and last one, which is number 5th, electronegativity. This is known as the electronegativity. Electronegativity. What is electronegativity? It is the tendency of an atom to accept electron pair towards itself in a covalent compound. Suppose beta we are talking about the HCl. Let's see, H and Cl. Cl has 7 electrons in its outermost shell, H has 1 electron. So therefore we can say H and Cl is forming covalent bond in it. So see, H and Cl, the element which has more electronegativity, means which is highly electronegative, that will attract the shared pair of electron towards itself. H and Cl, the electronegativity of Cl is 3 and the electronegativity of H is 2.1. So then it is greater, it will attract the shared pair of electron towards itself partially. So that's why we can say it will show the partial negative charge and it will show the partial positive charge. So we can say electronegativity is the characteristics or the tendency of an element to attract the shared pair of electron towards itself in a covalent compound. So this is known as the electronegativity. What is the trend beta? We can say that is trend when we will move in a period, so then it increases. How it will behave? It increases, and in the group it decreases. Okay, in the periods it increases and in the groups it decreases. The cause behind it, because atomic size decreases in the period, therefore electronegativity increases, and in group from top to bottom atomic size increases, therefore electronegativity decreases. So this is all about the periodic properties. Periodic properties means, again I am just briefing, periodic properties means which changes the properties of the elements, which changes after fixed interval of the time, that is known as the periodic properties. And I have told the different types of the periodic property along with the general trend, how it will decrease or how it will increase. In the period it will increase or decrease, in the group it will increase or decrease. So that is all about the periodic properties. I hope you understood. In the next class we will discuss another things. Thank you so much for watching.